Assalamualaikum and hi, my name is Syahira Binti Ahmad Khusyairi. So today I will be present about activity 1, open loop speed control system to observe the input voltage and tachometer voltage for different motor speed. Okay, so firstly, by using MATLAB Simulink, we have to construct the block diagram of an open loop speed control system as shown in figure 8.4, which is in our lab sheet, and then set the parameter value according to the list given in table 8.1. Okay, so firstly, we have input voltage here, and then electrical part of the transfer function, and the mechanical part of the transfer function. We also have some block, and then torque constant, tachometer constant, and then also scope for voltage input, motor torque, motor speed, and tachometer voltage. Okay, so firstly, um, the voltage input we have set to 240 volt. Okay, so the voltage, okay, so we can see that the voltage is also 240 volt for the voltage versus time waveform. And then for the electrical part, we have Km, which is the EMF constant, which is 0.516, and then we have Le, which is armature inductance 0.0281, and then add with the Re, armature resistance 2.581 ohm, and then we also have the mechanical part, which is the transfer function is 1 over JMS plus BM, which is moment of inertia of motor add with viscous frictional constant of motor BM. Okay, and then we also have the gain of tachometer constant 0.065 and torque constant 0.05. So we will see the motor torque waveform. Okay, so here, so if you want to read the waveform, just click on the ruler and then click on the waveform, so we can see the value of motor torque versus time. Okay, same with motor speed. Okay, this is the waveform for motor speed versus time, and then this is the tachometer voltage versus time waveform. Okay, so Aimi will continue to present about the next task for activity 1. Thank you.
Hello and Assalamualaikum. My name is Aimi Rauqah Binti Abdul Razak with the metric number EE180001. So today I would like to explain about the activity 1, which is open loop speed control system to observe the input voltage and tachometer voltage for different motor speed. So first, this is the second block diagram where it is a little bit different from the previous one. Where in this block diagram, I have added the tachometer constant after input speed to measure the input voltage when the tachometer constant is added. So for this experiment, there will be a various different values of motor speed to be included, so that we can know the pattern or the trend of input voltage and tachometer output after the value is entered. So for the first value, I will insert or pick or enter the value on the input speed. So here, for the first value that I choose is 400 RPM. So I will type the 400 value here, and then I click OK. And then after we click the value of input speed, we can run the simulation to know the value of input voltage and thermometer output after the simulation is ready. We can click on the input voltage to know the value. So the value here is that was appeared is 26 for the input, and for the tachometer output is also 26.03. So if you want to test it with another value, I can just change the value at the input speed with the same procedure as before. So I would choose 800 values, 800 RPM, sorry, for the initial and final value. And this experiment or this simulation will run for 10 seconds before we measure the input voltage and also tachometer output. So same as before, I will run the simulation. When the simulation is ready, I will just click on the input voltage to know the value. The value appeared is 52 voltage for the input, and also for the output is 52.06. For the one last kind of measurement, I will enter the value of 1200 RPM. Okay, so we will run the simulation again, and after the simulation is ready, we just click on the page. So yeah, we can see the value of 78 voltage appeared, and also for the input, and also for the tachometer output is also 78.09. With this experiment, by doing the three different values, we can know that the value of input voltage and also tachometer output is almost same. And as the value of motor speed increasing, the value of input voltage and also tachometer output is also increasing. So the further discussion and the graph will be included in the full report. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Batrisyia Balqis Binti Jaizan Hadi with metric number AA1X0040. And now I will continue on explaining activity 2, which is open loop. In this activity, we are required to set the input speed to 2500 RPM. And then we have to observe what is the input voltage. So after we insert the value of the speed, we run the simulation, and for the input voltage we get 162.5 volt. And second step that require us is to observe the speed output here when we change the break scale up to 3, which is 0, 3, 6 until 29. So first, when we set at 0, the speed output that we get is 2496 RPM. And when we change to 3 and run it, it becomes 2265. We try 6 and run it, and we got 2034 RPM. So here I try to jump to our break scale at 18. So here we get 1110, and for the tachometer output 72.50. Okay, as we can see here, when we change the brake scale increasingly, the speed output and tachometer output that we got is decreased from high value, and when we change to the highest brake scale, the output for speed and tachometer is decreasing. That's all for me.
Hello, my name is Nurol Binti Muhammad Nur Zaki and my metric number is AE180085. I'm going to present activity 3, which is closed loop speed control system. This is the block diagram of activity 3. It consists of input voltage, the proportional gain, the saturation, the DC motor, and the display that we will observe the motor speed graph. But first, we need to set the input voltage based on the value that obtained in activity 2, which is 162.5 volt. After we set it, we need to observe several brake scale value, which is first one 0, followed by 3, 6, 9, 12, 15, 18, and 21. For the first one, the brake scale is 0. We need to set the value as 0 and run the circuit. Before that, we need to set the time equal to 10 seconds. To see the graph, click the motor speed display. So this is the graph. After 10 seconds, the motor speed is equal to 2488 RPM. And that's the brake scale is equal to 0. For the middle one, the brake scale is 12. We need to set the value as 12 and run the circuit. To see the graph, click the motor speed display. So, this is the graph. After 10 seconds, the motor speed is equal to 2482 RPM. And that's the brake scale is equal to 12. And the last one, the brake scale is equal to 21. We need to set the value as 21 and run the circuit. To see the graph, click the motor speed display. So, this is the graph. After 10 seconds, the motor speed is equal to 2078 RPM and that's the brake scale is equal to 21. So, that's all from me. Thank you.